Now, having studied the polynomial equation, now we shall learn one more most important value of a polynomial of fx at x is equal to alpha. Value of a polynomial fx at x is equal to alpha. Let us take a polynomial fx is equal to a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus etc. a n minus 1 to the power of n minus x to the power of 1 plus an. We know it is a polynomial and it is denoted by fx. B, a polynomial in variable x of degree n provided a naught is not equal to 0. Leading term coefficient should not be equal to 0. And alpha be a real number. Alpha be a real number. Just like a naught, a1, a2, an minus 1, an. Similarly, alpha is a real number. Now, I will write one expression. A naught alpha to the power of n plus a1 alpha to the power of n minus 1 plus a2 alpha to the power of n minus 2 plus etc. plus an minus 1 alpha plus an. So what change you are going to notice between these two? X is replaced by alpha in every term except the constant term. This is called the value of the polynomial fx at x is equal to alpha, a real number. It is denoted by f of alpha. Now I am going to write. Therefore, f of alpha is equal to a naught alpha to the power of n plus a1 alpha to the power of n minus 1 plus a2 alpha to the power of n minus 2 plus an minus 1 alpha plus an. This is the value of the polynomial and this is denoted by f alpha. Now, value of a polynomial of fx at x is equal to alpha. Value at what point? That is important. So fx is equal to, consider the polynomial, be a polynomial in x of degree n and a naught not equal to 0 and alpha be a real number. See here a naught, from the definition we have understood, a naught, a1, a2, an minus 1, an are real numbers. And alpha is also a real number. See here we are writing. A real number multiplied by real number is a real number. So here we will get one more real number, one more real number, one more real number, one more real number. Sum of all real numbers is only a real number. So E is called the value, that is called a value of what? Of the polynomial fx. This is the value of the polynomial fx when x is equal to alpha. So, and it is denoted by the notation f alpha. So therefore f alpha is equal to a naught alpha power n plus a1 alpha to the power of n minus 1 plus a2 alpha to the power of n minus 2, etc. So all this is a real number. So this is the value of the polynomial fx at x is equal to alpha. This is very important, and we are using this to solve the many problems on factor theorem as well as remainder theorem. Now, after knowing the value of a polynomial fx at x is equal to alpha, we shall take some examples which strengthens the concept of value of the polynomial. So, example number 1. Let us take the polynomial fx is equal to 8x square minus 3x plus 7 be a polynomial. We all of you know, no need for further explanation. It is a polynomial of degree 2 in variable x. Now, we shall find some of the values. We shall find value of x at x is equal to minus 1 and value of the polynomial f when x is equal to 2 and value of the polynomial when x is equal to 0. Now we shall find one by one. Now, first we shall find f of minus 1. So here, in this step, we should replace the x value with minus 1. So now, I will replace x. Now I have replaced x. So in x place, I should write minus 1. That is, x is equal to minus 1. So here minus 1, minus 1, minus 1. So this is equal to, so 8 into minus 1 square is 1, minus into minus plus 3 into 1 plus 7. This is equal to 8 plus 3 plus 7. So 18. So the value of the polynomial at x is equal to minus 1 is 18. Similarly, now we shall calculate the value of the polynomial at x is equal to 2. So now I am going to write 8 into 2 square minus 3 into 2 plus 7. Note one thing here. Here I am using the brackets. Because of negative sign I am using brackets. Here 2 is positive one. So I am not writing the bracket. So this is equal to 8 into 4 minus 3 into 2 plus 7. So 32 minus 6 plus 7. So 32 plus 7 is 39 minus 6, that is 33. So we got the f of 2 is 33. Now we shall find the last one, that is value of the polynomial at x is equal to 0. So 8 into 0 square minus 3 into 0 plus 7. So 8 into 0 square is 0 minus 3 into 0 plus 7. This is equal to 0 minus 0 plus 7 is equal to 7. So therefore, f of 0 is equal to 7. So now we got three answers. F of minus 1 is 18, f of 2 is 33, and f of 0 is 7. This is, see here, in this problem, this is our polynomial. Fx is equal to a naught x to the power of n plus a1 x to the power of n minus 1. We know the polynomial. And this minus 1 happens to be alpha. So at x is equal to alpha. In this problem, alpha is minus 1. In this problem, alpha is 2. In this problem, alpha is 0. So we shall substitute. So in this problem, what we are using? We are using the concept of substitution. So x is replaced by -1 in the first problem. In the second problem, x is replaced with 2. And in third problem, x is replaced with 0. So this is 18 is the value of the polynomial fx at x is equal to -1. Now 33 is the value of the polynomial fx at x is equal to 2. Then f0 is equal to 7. 7 is the value of the polynomial fx at x is equal to 0. These are the three examples for first case. Now we shall take second example. Let us take the polynomial fx is equal to 2x cube minus 13x square plus 17x plus 12. This is a cubic polynomial because the highest power is 3 and this itself is the leading term. So it is a cubic polynomial. Now we are to find the value of f of x at x is equal to minus 1 by 2. This is my object. Now, and also we shall find f of 1. Both we shall find. Now, we shall set x is equal to minus half. F of minus half is equal to 2 into minus half whole cube minus 13 into minus half whole square plus 17 into minus half plus 12. Now this is equal to 2 into, here the power is 3. So here minus sign is there. So answer you will get minus sign because 3 is a odd number. So 1 cube is 1, 2 cube is 2 into 2 into 2, that is 8. So then minus 13 into, yes, minus whole square, 2 is an even number, so you will get plus. So 1 by 2 square, that is 4. Then plus into minus, minus 17 into 1 by 2 plus 12. Now we shall simplify. Minus 1 by 4 minus 13 by 4 minus 17 by 2 plus 12 means 12 by 1. Take the LCM. So LCM is 4 minus 1 minus 13 minus 34 plus 48. This is equal to minus 14 minus 14 minus 34 minus 48 minus 48 plus 48 by 4, that is 0 by 4, that is 0. Now here this is important. Here I used to tell this is most important concept. A by A is 1, A minus A is 0. So often we use this in mathematics. So we got f of minus 1 by 2 is equal to 0. Now the value of the polynomial 0 is the value of the polynomial fx at x is equal to minus 1 by 2. Now he is asking f of 1 also. Now here I am going to do the problem. So f of 1 is equal to 2 into 1 cube minus 13 into 1 square plus 17 into 1 plus 12. That is 2 into 1 minus 13 into 1 plus 17 into 1 plus 12. That is 2 minus 13 plus 17 plus 12. So 29, 31 minus 13, which is equal to 17, 18. So 18 is the, so therefore f of 1 is equal to 18. So 18 is the value of the polynomial fx at x is equal to 1. 0 is the value of the polynomial fx at x is equal to minus 1 by 2. Here you got f of minus 1 is 0. We can say minus 1 by 2 is a root of the polynomial fx. If you get answer as 0, if you get value of the polynomial 0, then clearly we can say minus 1 by 2 is a root of the polynomial. This polynomial. Yes. Now with all this, before going to the factor theorem and remainder theorem, one of the most important concepts you have to know, that is called as division algorithm. Division algorithm. Now I am going to take one small example, which you know. We will take one integer 10 and we shall divide it by 2. Now I will divide 10 by 2. Suppose I will take 1, 2 1 2, that is 8, 2 2 4, that is 6, 2 3 9, 3 6, that is 4, 2 4 4 8, that is 2, 2 5 10, 0, 2 6 plus minus 2. Now we should tell which is division algorithm among all these. As you know, this is the dividend, this is divisor, this is quotient, and this is the remainder. Remainder should be 0 and it should be less than the divisor. Then only we will call this as division algorithm. All these are not all division algorithms. These are not at all division algorithms. Why? Because 8 which is not equal to 0 and it is not less than 2. So we will reject. 6 less than 2, false. So 4 less than 2, false. 2 less than 2, false. 0 is less than 2. And it is less than, this is called as remainder. Minus 2 less than the divisor. This is also false. Now I will take one more example. 10 by 3. Suppose I will take 10 and divide by 3. 3 3 is 9. This is 1. This is the division algorithm. Suppose if you take 3 2 is 6 4. This is not division algorithm. Why? Because 4 is less than 3 is false. 1 is less than 3 is true. Similarly, 2 4 is 12 minus 2. So we are dividing by 3. Okay, 3 4 is 12. So minus 2. Now this is the division algorithm. 1 is less than 3. So that the remainder, it should, to become remainder, it should be less than the divisor. So this is the division algorithm. In this case, this is the division algorithm. So the most fundamental concept is the remainder the remainder should be 0 or it is less than the divisor. It should be 0 or less than divisor. This condition needs to be satisfied. Then only we say it is a case of division algorithm. Having known the numerical example of two integers and understanding the division algorithm, now we shall take polynomials. So we have learned what are the different types of polynomials, how it is divided, and what are the leading terms, constant term, degree of a polynomial. Now we are after using those concepts to develop the theorem, factor theorem, and the remainder theorem. Now we shall take some polynomials. Division algorithm. Division algorithm for polynomials. Polynomials. On dividing a polynomial fx by another polynomial gx, let the quotient be a polynomial qx and the remainder be a polynomial Rx. Then we have, see here, on dividing a polynomial fx. So here there is one polynomial fx. So we should divide this polynomial by one more polynomial called gx. So this happens to be the numerator and this happens to be the denominator. So now we shall take the denominator here, gx. Now we are going to divide. Let quotient be a polynomial qx. So quotient is the polynomial qx. Now we shall multiply gx into qx. After multiplying, we have to subtract. So that is fx minus gx into qx. This is nothing but your remainder polynomial Rx. So on dividing a polynomial fx, this is called as dividend. This gx is called as divisor and this qx is called as quotient and this Rx is called as remainder. So divisor is a polynomial and it is denoted by gx. Dividend is a polynomial, it is denoted by fx. Quotient is a polynomial which is denoted by qx, and this is the product of divisor and the quotient. On subtracting, we got one more polynomial Rx called the remainder. Now we shall frame the relation between these two. See here, it's very simple. You can imagine like this. So when we divide 2 5 is 10. So 0 we got. So that means 0 is equal to half 2. This is nothing but 2 into 5. So subtract. So this is your remainder. 0 is equal to 10 minus 2 into 5. So similarly, you can write now I want to find the remainder. So fx. So Rx is equal to this. Now this is equal to, keep fx there only, RHS, and transpose this term to LHS. So we'll get Gx into Qx plus Rx. So we can write like conversely, we can write fx is equal to Gx into Qx plus Rx. So this is what formula. That is, we can write like this. Fx is nothing but dividend. So dividend is equal to, your Gx is nothing but divisor. Divisor into Qx is nothing but quotient plus Rx is nothing but remainder. So dividend is equal to divisor into quotient plus remainder. So here the degree of Rx must be 0, or the degree of Rx should be less than degree of Gx, means divisor. So degree of the remainder should be less than the degree of the divisor, or it should be a 0. This is very, very important. Degree of a remainder is less than degree of divisor for a division algorithm. So now I am going to summarize. Division algorithm for polynomials. Take one polynomial and divide by Gx. So on dividing a polynomial fx by a polynomial Gx, let the quotient be the polynomial Qx and the remainder be the polynomial Rx. Then we know this. Fx, we divide by Gx, you will get the quotient, take the product and subtract. So what we will get? We will get the remainder. So, and Gx, if I am transposing this term to LHS, so we will get Gx into Qx plus Rx is equal to Fx. Conversely, means RHS, you write it as LHS and take LHS as RHS. Fx is equal to Gx into Qx plus Rx. That means dividend is equal to divisor into quotient plus remainder. And note that the remainder should be 0, or degree of remainder is less than degree of divisor. So this is very, very important to understand the factor theorem. Now after this we are going to prove the factor theorem. This will help us to prove the factor theorem and also the previous concept what we have learned earlier. Now, before going to factor theorem, we are taking one division problem, that is division algorithm, with polynomials. And we will do the same problem with a different method. We will get the same, both the answers will be same. From that we can conclude what is our remainder factor theorem and what is the remainder theorem. Now we shall take that example. Let us divide 2x cube minus 7x square plus 5x minus 9 by 2x minus 3. This is my problem. Now, this is a polynomial and this is also a polynomial. This is a binomial, this is a polynomial, multinomial. Now we shall denote this polynomial with fx. Fx is equal to 2x cube minus 7x square plus 5x minus 9. Now we shall divide the 2x square minus 7x square plus 5x minus 9 by that gx, that is 2x minus 3. This is our dividend and this is the divisor. Now I have to find the quotient. Now the sign is plus here. Here also it is plus. So 2 is there. I want the sign. First I should take care of sign. Plus is there. So I want the answer as plus. That process is like this. For plus, what should be the sign should be multiplied to get the same plus. So it is nothing but plus. This plus is this plus. And this plus is this plus. This plus should write here. Plus 2 is there. I want 2. So it should be 1. Then x is there. I want x square. So I should write here x. Now, so plus into plus. Plus 2x into 1x. 2 1 2. X into x. So it should be x cube. So this should be x square. Here you will get x cube. Now, so you have to multiply this with this second term. Plus into minus, minus 3 1 3 x square. Now, we shall subtract. Before subtracting, we should change the sign. So this gets cancels. Minus 7 plus 3x square. So you will get minus 4x square plus 5x minus 9. Now, here at this stage, the degree is 3. So the degree is 3 and the degree of denominator is, this is 1. Now I have divided. Next is, I should write minus here because plus is there. So plus into minus, minus 2x is there. So I should write 2. So that I will get 4 and x is there. So if I write x, then I will get x square. Next, minus into minus plus 2x into 3, that is 6x. Subtract. So now we got plus minus, this will cancel, minus 1x minus 9. This is here the degree is 2 and degree is 1. Minus 1x minus 9. Now, here minus sign is there. So, plus into minus, minus. So, 2 is there. I want 1. So, I should write here half. So, I will get 1 next. Then, minus into plus. So, minus into minus plus 3 by 2. Change the sign and add. So, minus 9 minus 3 by 2. So 2 is the LCM, minus 18, minus 3, that is minus 21 by 2. Now, this is your remainder. Remainder is minus 21 by 2. Now, at this stage, so degree is 3 and degree is 1 here. So, at this stage, degree is 2 and degree is 1. At this stage, degree is 1 and equal degree. See, it is improper, this is improper, this is still improper. But here, it becomes a proper. So, here we have to stop. So, this is to be continued, here we should continue. So, why I am writing like this means, in the process of division, this is to be taken care. The process of division begins, but where it ends, that is important. So, here it ends. So, we got the degrees So this is your dividend, divisor, quotient and the remainder. Now we shall do the same problem by one more method in the next problem.